Hello everyone, today we are going to calculate diffusion energy of element like hydrogen, oxygen or nitrogen or anyone you like. As this is only a demo video, I will be using express settings so the result will not be very accurate. You should choose minimum, medium or fine settings to have a good result. So this is the iron structure. First of all, we need to do its geometry optimization. You can refer my previous video. I will put the link in the description. Okay, the geometry optimization is completed. So and this is the optimized structure. Copy this structure from here and paste it in the main folder. Paste it, rename it as initial. Now what we want to do is have a hydrogen atom at the top surface. Let's check is here the latest parameter. Now what we want to do is to put a hydrogen atom on the top surface and move it on the side surface. So first of all, let's add atom here. So it's right here. This is the latest parameter, so we want to do on the top surface. So we have atom here. It's a little bit above than the top surface, so it shows down here. So we can move it easily and bring it to the top surface. Close these boxes and just use these parameters and get it on the top surface and recalculate bonds. So we have a hydrogen atom at this surface and we want to calculate the diffusion energy if it goes to the side surface. So now if this is exact center, now copy this structure again and again paste it here. Open this one, rename it as final. So this is at the top surface. Now move it to the side of the surface for our final diffusion. So this atom will now diffuse from top surface to the side surface. So after that, recalculate the bonds. This is our final structure. So this is our initial and final structure. So now what we have to do is to go to tools and this equivalent atoms. So now our first reactant is initial and final. So you can see here auto match. So the all the atoms in these two structures are matched perfectly. So now go to this third option reactant. Now the initial is our reactant and the final is our product, and it will show how to diffuse the atom from one place to another. So here open this one. This is our transition. You can play atom here. So it is 100 frames. This is how atom will diffuse from one position to another. If you don't see these values here, go to view, toolbar and here animation. So it is vanished. So view again, go to toolbar again and animation. So here it is again. So now open up CASTEP calculation and here choose TS search. I will be using express settings. So here everything is okay. No need to check any properties. You should choose 2 cores as it will take a lot of memory. So runtime optimization, choose memory, click run. It will take almost half an hour to optimize this. Okay, this is complete. Open up the CASTEP file. Go at the very bottom. Now here, go a little bit above. Now this table is very important. Here you have your energies values, energy of the reactants, energy of the products, and the transition state energy. As you can see, the transition state energy is lowest. As this is the demo, I did not have a very accurate structure and very accurate energy. So in this, the barrier is in negative. That means the activation energy is in negative. The transition state is more stable than the initial and the final state. Now, to confirm these values, there is another calculation. Go to CASTEP. Now, from TS search, go to TS confirmation and then run again. Now they already have a TS search data transition state data, so it will only confirm this that this data is accurate. It will take a few minutes. So now the transition state confirmation is complete. So this is the reactant and this is the product, where the atom is at the center of the surface face. So this is the transition state and it has the lowest energy. So this is how you calculate the diffusion energy of your structure. Hit like if you like the video and subscribe to my channel and share it with your friends. Thank you guys.